Okay, first of all, before I get started, can everyone hear me? Can you give me a thumbs up if you can? Awesome. Okay, let's keep that energy. Um, Before I crack on properly, I've been asked to ask you to turn off your mobile phones, and because you're not going to do that, to take them out of your pocket and look at them sternly, and then maybe turn off the ringers. My concentration is shot completely anyway, so it won't affect me either way, but as a courtesy to your fellow attendees. Awesome. Okay, so my name is Séamus, and I work at a company called Failbetter Games as a programmer. I just want to talk a little bit before I crack into detail about who we are and what we do. So we might be best known for our very, very long-running browser-based interactive fiction RPG, Fallen London, which kicked off in 2009 and will be eligible to ride a moped at Christmas of next year, which is very unlikely, unusual for live service games along several axes, right? In 2015, we brought out our first Unity premium game, Sunless Sea, which is again, narrative-heavy, exploration-focused RPG that features a considerable amount of cannibalism. In 2019, we brought out Sunless Skies, its sequel, which was even larger, but this time set in space with somewhat less cannibalism. And last year, we released Mask of the Rose, which is our youngest and, in many ways, strangest child, despite the fact that it features no cannibalism at all. If you know our work and you know the team, you probably know that we're a small bunch of folks who make big, narratively ambitious games. How big? Well, we did the numbers on this before this talk. These days, Fallen London clocks in at about just under 4.5 million words, which is about 5 times the length of the complete works of William Shakespeare. As a smaller one-off game rather than live service, Sunless Sea weighs in at a mere 300,000, which is only about 0.4 Shakespeare's. Sunless Skies, larger, more ambitious, we got up to 800,000, which is just under 0.9 Shakespeare's, let's say. And Mask of the Rose is harder to enumerate and assess for reasons that basically form the basis for this talk. So in my rating system, I give it one tentacled monstrosity from a cold and distant star. Okay, so what is Mask of the Rose? Well, it's a combination of a murder mystery and a romantic comedy in a visual novel format. The framing story is that somebody dies, comes back to life, and enlists you to help solve his murder. Meanwhile, you're running around an alternate Victorian London, trying to fall in love yourself or maybe help other people get matched up. It's implemented in Ink, which if you're coming from the sort of interactive fiction or branch narrative community, you're probably familiar with, developed by our friends at Inkle. We kickstarted it way back in January 2021 and hit production about 6 months later in June, eventually launching pretty much exactly 2 years later. The core team was initially 3 people, a writer, an artist, and a programmer. It later expanded to 4 when QA came on board full-time. As production went on, we had people sort of joining in for smaller bits to help fix bugs or to work on content, but we never really extended beyond 6 people. You could always fit a planning meeting around a restaurant table, put it that way. I'm mentioning these numbers for a couple of reasons. Well, really just one. As I go through the rest of these slides, I'm going to be saying things like, well, we couldn't do X and we weren't able to do Y in the time available. And the response to the very reasonable question, well, why not, is probably one of the numbers that you see here, right? It was a fairly small team and not particularly generous development timetable. Thematically and in terms of genre, Mask of the Roses is probably quite familiar. I'm going to dispense with it in about 4 slides. The core of the game loop looks like this. You are an unseen protagonist engaging in dialogue with one or more NPCs at a time. Dialogue progresses, you make choices, and dialogue progresses from there. There's also an outfit changing mechanic, and the choices you make here about what to wear inform the conversation outfits. I want to draw your attention to this hat and this bouquet, not just because they're lovely pieces of art by our art director, Paul Arend, but also because they feature importantly in an upcoming slide. So we have 4 slots, about 8 options per slot, so there's around 4,000 different item combos available. You can also move around the City of London, you go to different places and different NPCs are available to talk to. They have their own routines, they may be present or absent, they may be doing their own thing, and you kind of have to fit into that. And finally, we had this mini game called Story Crafting, in which you can go around London, acquire tokens in the form of concepts or people, and use them to dynamically generate narratives. This one screen was sufficiently complex that it got turned ultimately into a talk at the Experimental Games Workshop at GDC this year. So I'm not going to go into any detail about it whatsoever today, and just say, look, our visual novel also had a minigame. Okay. So what was weird about Mask was that, unlike most visual novels, which are often a very directed experience, they're linear, or they're linear with branches, or within those branches they're quite linear. We adopted something we called systems over scripts for Mask. Outside one or two major set pieces, the game state drives the narrative, which is generated based on models and systems rather than fixed scripts. At runtime, the dialogue that you play through is being procedurally assembled by these systems. I use assembled here rather than generated, because I think procedural generation implies that there's some sort of language model that is generating the output, whereas enormous amounts of work went into handcrafting our dialogue. I'm not boasting here, I just want to give you a sense of the amount of writer effort that was involved in building it. And finally, there are no false choices, which is, a big advertising point, right? But we took the concept of choices having consequences to its absolute logical extreme. In Mask, every single dialogue choice that you make causes either an immediate branch in the narrative or updates a state variable that will change the narrative in the future. And if you can see the pain in my eyes now, it definitely does do all of these things. And to give you an idea of the complexity, I want to just look at the anatomy of a single frame. So this is dialogue with a character called Harjit here, who's a local policeman. And you are asking him for a piece of census information, his romantic inclinations or otherwise. It makes sense within the law, I promise. And what has happened here is that piece of information is one that Harjit's NPC model recognizes as something that a piece of information that he should only give to somebody with whom he has a trust-based relationship. And this is quite early in the game, so we're not at that point yet. So I have some dialogue choices here. And you can see the markers here and here. So the first choice is available to me because I happen to be wearing that bouquet of flowers that I asked you to pay special attention to. That bouquet of flowers tells the system that I should be able to make boastful or flamboyant dialogue choices. So the system that comes up with responses for me will privilege those. The hat derives from the fact that I'm wearing the Admiral's hat that I also asked you to look at. That hat gives me dialogue options that are authoritarian or commanding. And finally, the third option is available to me because way back in character creation at the start of the game, I indicated that my character came from a former family of dock workers. So if Harjit knew me better, or if I were dressed differently, all of these options would be different. And most important and problematically, this isn't anywhere in our narrative logic. If you go looking for the particular part that has this prompt and these dialogue choices, it doesn't exist because it was generated at runtime. What could possibly go wrong with a system as complicated as that? Well, it turned out quite a lot. So as I said earlier, we went into production before our QA was fully available. And she came on board and started doing to our lovely game what QAs do, and came back telling us that she kept just running out of things to say. And she would get into a soft lock situation where she had no option but to quit back to the title, reload a save, make different choices. We called this the soft lock problem, and you can kind of see where it comes from. So this is Inc syntax. It doesn't matter if you're not familiar with it, because I'm going to talk through it. Here, we're just defining the times of day that the player is able to be active as basically an enum of three: the morning, the afternoon, the evening. And when we enter a piece of content, we look at whatever variable value the current time is. If it's the morning, we give them some morning choices. If it's the afternoon, we give them some afternoon choices, and so on. Okay, so far so good. And then we have this conversation about what a boring life the PC has, and we decide to give them the option to do stuff at night. And now, if we hit this piece of content during the night, we've got nothing to show the PC. We've got nothing for them to do, and we just run out of road. Fortunately, the runtime hits throws an error, but we needed to actually play through to find a problem like this. And we didn't just have this problem, we had this problem on a narratively ambitious scale. There are around 40,000 lines of ink in the project narrative logic. Complete playthrough isn't terribly long, it's between 4 and 5 hours, but if you think of that in terms of a QA playing through the game to make sure it's end-to-end completable, that's a little bit less than 2 playthroughs per day, right? During those 4 to 5 hours, you're going to reach something comfortably in the length range of a novella rather than a novel, but that also has to make sense for us to sell it. You're going to make around 7,000 choices, and your choices are going to update on the order of 1,200 narrative state variables. We don't know how many different routes there are. We're definitely sure that it's more than millions, so I'm confident to say that it's more than millions, but the real number is something out there, hence my rating. So, I mean, how do you test a game like this, right? It's enormous, it's weighty. Well, there are a few options, and the first option, of course, is the tried and true option that we use for testing games: humans. So we all understand how to make a build, give it to someone, get them to tell you about it, analyze your content by by executing your content. There are still a few of us humans left in the games industry. Thank God. Programmers and designers, we hope, test our own work. QA tests it for us. We send it on to play testers and beta testers, internally or externally. And then we send it out to the general public, and they get the game and they test it, and they leave forgiving and understanding comments on your Steam forum page. So humans are fantastic, and some of my best friends and so on. They have a number of benefits. First of all, they're real people, mostly. They will give you the closest thing you can possibly get to the actual user experience that you're hoping to send out into the world. You cannot beat that. Secondly, for anything that's remotely subjective, we've found, at least at Failbetter, that we can't at least use things like sentiment analysis to beat the human ability to say something like, this game doesn't feel like it works. And the third thing that I love most is that a good QA is like a toddler. They will always manage to find the fork, the socket, the pan of boiling water that wasn't there before they came in. Whether you want them or not to find your bugs, they will find them. Humans, fantastic, love them. But they have their downsides. First of all, they're slow. And that's not really their fault, but a QA playing your game is playing your game, and they're playing the experience that you intended to deliver to the user. So if you have something like nice text animations that they have to sit through to play through the narrative content, they have to spend time doing that. If they need to do non-narrative stuff, go acquire resources, go kill some orcs, to come back to progress with the narrative, they have to spend time doing that as well. You can give them debug tools to mitigate that, but the more they skip, the less their interaction with the game represents what you're giving to the players. They need to stay below a certain scale. Certainly at our scale, you don't have 24/7 tester coverage. So if your writers are working at a time that your QA isn't around, they can't test the content until they're ready. Basically, you can only have your QAs test the game when your QAs are able to sit in front of a computer to do so. They're expensive. They are not nearly as expensive as they deserve to be, obviously. But every hour of bugs that you as a writer or programmer put into your game is an hour that a QA has to spend finding and fixing that, which if you have 20 QA testers worth of bugs and you can only afford to hire QA testers, you have a problem. The lever that we traditionally pull here, I think, in the industry is crunch, but that's a fundamentally unserious approach to being a human being, so I'll skip that. More important than the raw cost is that there's an opportunity cost to narrative testing. So if your QA is testing the narrative in your game, they're not testing the tech, they're not testing the UI, they're not testing the art, they're not finding the audio bugs, they're not doing all the other things that they are so fantastic at doing. So, all right. So analyzing human content by having a human execute it isn't enough. What could we do? Well, could we maybe do the opposite? Can you not execute it? Well, you could. You could attempt to analyze your content without actually executing it, by which I mean static analysis. And the question that we found ourselves asking when we realized we were overmatched in terms of bugs and QA time was, could we just look at the structure? And could we infer stuff about the game from its structure? And we thought about graphs, and graphs are pretty ubiquitous, at least in my part of the game dev world. We often design our games with graphs, like this puzzle dependency chart for the most recent Return to Monkey Island. There are very minor early game spoilers here. If you have a game design document, there's a good chance you have something like this in here. And having thought about our games and planned them out in terms of graphs, we often go on to build tools that replicate those structures. So this is RTC Draft, but you have like Arcweave, Quest Machine, various dialogue systems. If you have an in-house dialogue system that you've built, it possibly looks a lot like this. Even the guiding metaphor of ink, although it's text-based, is one of knots or nodes of content being connected by tunnels or edges and so on. So graphs are great. Mathematicians have been fascinated with them for nearly 300 years, ever since Euler tried to work out whether you could cross all the bridges in Königsberg without doing so twice over one. It turns out that you can't, but he had such a great time that they've spent the 300 years since interrogating, defining, and proving the properties of graphs. Computer scientists, who were basically mathematicians with a palette swap, have also been as fascinated with graphs and have been implementing, defining, and proving the optimality of graph-based algorithms for as long as computer science has been a discipline. So if you have a problem, then graph theory can help you with the one proviso that your problem has to be a graph. What are the things you can do? Oh, and the nice thing is that your favorite language probably has a mature, full-featured graph library, so you don't have to build this stuff from scratch. You can just find something that works for you. Even Rust has a graph library, I was impressed to learn. What are the things you can find out? Well, the first thing was reachability and connectivity, which was the problem that we were experiencing. Could players get to our content, and could they then get back out of it? You can also ask a graphical version of your narrative about what the shortest path is. So how long does it take to complete? Are there any sequence breaks that you didn't intend there to be? What are the costs of moving through a graph? How many resources, how many rats do they have to kill to get to level 2 in the Fighters Guild, that kind of stuff? And what are the rewards? So what is your content that you're writing doing to your in-game economy? And that's especially important when you're adding new content to an existing economy. And I bring it up mostly because we do have a problem that is a graph at Failbetter, and that problem is Fallen London, our very long-running narrative RPG. So we developed this with an in-house engine called Story Nexus, and the core gameplay loop presents a framing context up here, then a set of options you can take to proceed. So we, internally and in player-facing comms, we call these things events, but they're really just nodes in a graph. And then the branches that we present are really just edges in the same graph. So if you graph out for London, it looks a little bit like this. This is quite old, it's about 8 years old, and represents an attempt by one of our users to map out the structure of the 4 kind of main quests. For London has about 45,000 nodes and about 30,000 edges. So it's a big, hefty graph. We like it a lot. In-game resource collection is a really important part of Fallen London. So tuning, especially new content, is important for us because we don't want to put out a content update and have the players say, this content, the rewards are awful, or we don't, even worse, this content is fantastic because it's broken the in-game economy. Our players spreadsheet out our economy, so it's only fair for us to try and do the same. And it turned out that about a year before we'd gone into production at Mask, we had looked specifically at what the economic benefits of moving through content in Fallen London looked like from a graphical perspective. And this is just a very simple abstraction of that. You can imagine that from starting at an initial node here, with some random probability, you move through 3 different edges and then onto some further content. And this is a very simple bit of statistics to work out, multiply the probability by the reward. And we could work out that the expected value in our in-game currency was 5.4 here. And we have a lot of loopy content that turns into resource grinds, and having some insight over the structure like this gave us the ability to tune that before we put it out. So having had that success, we asked ourselves, well, is Mask of the Rose a graph? And I got together with the smarter people who work on the Fallen London team, and we looked at mask, and they said ultimately no. Well, that's not quite true. Mask is a finite representation of a world, right? There are only so many states that exist. So yes, it is. It does have some latent graphical structure. But the thing is that it's just an absolutely massive latent graphical structure, particularly when you think about the just over 4,000 outfit choices that a player can take going into a piece of content. Every time the player left the house in a particular outfit, the size of the graph just increased by another couple of orders of magnitude. And we just didn't see a way in which we could model the content in order to analyze it fast enough so that it wouldn't be invalidated by the next new content coming down the pike. So analyzing content via human execution wasn't enough. Analyzing it without execution wasn't going to work. So then the question we asked ourselves was, is there, as there often is in narrative fiction, a secret third path? Is there something that we could use that doesn't have the benefits of human users, but maybe doesn't have all the drawbacks? Something that doesn't need to eat or sleep or get paid. And of course, yeah, there is computers. So somewhere in our code is a class that looks a little bit like this. It is, unfortunately, literally called the narrative God object because it's the God object that controls the narrative. And the central game loop just involves waiting for the UI to show some choices to the user, waiting for the user to make up their mind, updating the state, and then going back to the start and repeating until, for better or for worse, you've run out of things to do. If I sort of graph that out, it looks really nice like this, and you don't need me to tell you that when we started working on this, this is not what the code actually looked like. We had achievements mixed into this, we had animations, we had audio calls, we had various UI things. We hadn't architected our code for any kind of testability by a computer, so the first thing we had to do was disentangle all these dependencies and work our way down to sort of boil it down, burn away the impurities, and come up with something that did look in our code architecture a bit like this. And from there, it's not really a very big conceptual leap to come up with a system like this. Some sort of computer thing that will talk to the narrative God object, that will make choices, and will do some kind of logging or analysis of the choices that will tell you when you've run out of stuff. And then you can just feed it some sort of random seed so that you can have it make different choices every time you run it, but you can reproduce the test results. So the implementation of our narrative, what we call the autoplayer, was very, very straightforward. Start by abstracting and mocking out your non-narrative gameplay. So if you have outfit choices, work out a way that a computer can randomly, let's say, choose an outfit. Write something that will work against this API whose architecture you've defined. Make the choices at random, log out the roots, and call it done. We implemented this after we've been in production for about 8 months and managed to get the average time to execute from between 4 and 5 hours for a human down to about 8 seconds, which is about as slow as we could possibly make it. But that was still a 2,000 times speed up. So what we would do is we'd have writers would check in new content, then they or our QA would run the autoplayer over and over and over again. This would spit out the number of times we got to a successful end state, the number of times the engine failed out, having run out of content. We could also map out which endings we were more likely to reach through a random playthrough, suggesting that some end states were harder to find than others. We then fixed issues, and we repeated. And we did this over and over again on the existing content. Worked quite hard on it for a few weeks, and the results we found were really, really fast. Straight away, with the system in place, the reports from our QA about soft lock situations that you've been giving to us in droves before we implemented this essentially dried up. We were able to fix them before they reached her, which was fantastic. So we were in a pretty good state. Our players could definitely finish the game. And the most important thing, of course, is that they can get to the credits where your name is. So that was great, but we had this other problem, which was that it didn't always make sense at the end of the game. we started getting bugs. Instead of "I can't finish the game," they would say things like, "Well, the pacing on this part of the content doesn't really seem right," or "the options don't necessarily accurately reflect the state of the game," or "I actually don't know what this is about, but it's in there. It was obviously wrong and needed to be fixed." So was there something we could do about this, right? We were in a situation where logically the state should look like this, but it was turning out, when used in anger, to look like this. And we had a little bit of a think about how we would fix this if it was just a coding problem. And we came up with, we stole a technique from software development, namely assertions. So the programmers in the audience will know what I'm talking about straight away. For the rest of you, I'll just explain very briefly that an assertion is essentially just a small function or statement that evaluates some kind of condition. And if the condition is true, does nothing. And if the condition is false, does something noisy and unpleasant. You might choose to have a failed assertion crash your game. You might choose to just log an error. You might have it fail a test in a testing environment. And this is actually pretty much what we did. We wrote this function that if the condition failed, the run failed in a testing situation, but in builds, it would just log out an error. If we had been really concerned about the performance of the narrative loop, we could have just compiled this out entirely. Of course, that's always an option. That meant we could start putting it into places. So here is some sample content. I don't think it's actually real content, but a situation in which you're interacting with the character David, and you've entered a state where you would like to, get romantic with him. Even though death isn't permanent in the fictional universe that Master of the Rose takes place in, you shouldn't be able to romance people while they are literally dead. So we have this assertion that, well, okay, if we're entering this content, it doesn't make sense. We should have done something to check that David is not dead. And if he is, before we move on to any of this, let's just throw an error. And if, of course, the condition holds, we just carry on with this dialogue. I wrote this, but our writers are actually good at this kind of thing. So the workflow was pretty simple, right? We'd find something in testing that didn't work. We'd go to where it was broken and we'd write an assertion that it did work. And you're almost done at this point, but there are just a few more steps. We would then hopefully fix the bug, work out what conditions had failed to hold that had let us come into this bad situation, and then run the autoplayer. So this loop of finding an issue, writing a test, verifying that the fix works, and so on, might be familiar to some of you from a programming background. These were great. They are, as you can see, they're very cheap to write. It's a single line for a writer to add to some procedural narrative content. They're not complicated either. There are really only two things. Does this condition that we expect to be true, and this message that we pipe out somewhere if it isn't. And our writers really love them. They started adding them. And they started adding them not just in response to bugs from QA, but proactively. So we found ourselves in a situation where our writers were asserting the preconditions about narrative state without any prompting from QA or from programming. They were interested in doing it themselves. They wanted to make sure that their content worked. I was overjoyed, obviously, because our writers are very cool people, but I had somehow managed to drag them down to my level, which was personally highly satisfying. So, at this point in development, with the autoplayer to patiently run through our content over and over looking for errors, and with a way to identify the causes and fix the causes of specific state errors, we were looking pretty good. We had a release date, and things were tipping along very nicely. But it was still kind of time-consuming for QA to play through our content. If they needed a save file from a particular point in the game, they needed to start the game from scratch and play it through to that point. And at this point, we were noticing that parts of the content that were complete were getting broken when new content was coming in. Something was changing about the underlying system, some tweak to make something new work. was causing regressions in the existing content. So our lead writer, Emily Short, stole this terminology, concept of blessed scripts, from Inform 7, and we used it ourselves. So just a blessed script is basically just you've done a playthrough of a game in which you've provided inputs that you know lead to a good state, and you store some of these, and then you work out how to play those inputs back against some new state of the game and see what happens and fix what broke. So we didn't have a way to do this, but we were a little bit closer to having a way to do this because we'd done all that hard graft to make our game targetable by a random player. We stole another idea from web development, this idea of dispatching actions. So during play, we would listen for important stuff that the player was doing. So we would generally ignore things like opening the pause menu, but taking dialogue choices, changing their outfits and so on, turn those into something serializable, and then to execute it, deserialize, pass what we produced, and then plug it into the state to update the state. And then in theory, at the end, you'd get some kind of valid game state, or you'd get a breakage, in which case you'd be able to work out what had happened. If I graph this out, it's fairly straightforward. This is mostly the diagram that we had earlier, with the addition of just sort of pumping out some kind of encapsulation of how the game has changed to something that records it and sends it onto the file system. The content that we were actually sending out was very, very straightforward, right? If somebody made a choice, we just create an object that had that type and a payload of what the choice was. If they changed their outfit, we'd note that. If they traveled and so on. And then we just simply go pretty much in the opposite direction, come from the file system, pass those line after line after line of actions, send them to the narrative God object, pump out logging and analytics in the same way that we did with the autoplayer, and then finish up by creating some kind of valid save state that could be reused by our QAs if they wanted to proceed from that state. So this made regressions much, much easier to catch, right? We had this battery of existing good playthroughs. We'd get some new content checked in by the writers, and we would just run these inputs and see what had broken. It also meant that our QAs could generate saves from the middle of the game. If they needed to go back to the start, and if they needed to start from halfway through the game, they could just run a partial playthrough, get a save, and then carry on from there. And it really saved our bacon after launch. We patched the game a couple of times, and needed to make sure that our save games wouldn't break. And the main weapon in our arsenal that we used for that was to have a bunch of playthroughs that we knew worked, test them against patched content, make sure that everything was okay. So that's it. We didn't do everything right along the way, and I'm just going to talk briefly about the kind of two things that we did wrong. I've been spending a lot of time on LinkedIn coming up to develop, so I'm going to do so in the form of two sententious aphorisms. The first is that all models are wrong. Tone and balance didn't get fixed by any of our automatic testing. We still needed human input for that. And some of the feedback that we got when we first launched the game was, hey, your game is really, really hard. And it turned out our game was really hard. And that wasn't something that we could test for. Of course, some models are useful, but our mocked implementations of say, our mini games or some of our outfits, choice mechanics, sort of glossed over sometimes some real problems that players faced. There was excellent ROI, fantastic return on investment of the time that we put in, the engineering time that we put in, but it could have been better than it was. We had to retrofit retrofitting code to tuning into existing code took time and effort that it wouldn't have taken if we'd had a cleaner architecture to start with. We did benefit from having cleaner code as a result of the testing, but it was a longer and more unpleasant experience. One of the things we thought about when we got to the end of this was that maybe, hey, if you can test your narrative content, maybe you could also test your code. But I won't get into that today because it's a religious holy war, right? Okay, so we launched Mask last year, and eventually moved on to our new project, which I'd love to talk about, but my communications director is right here, so I can't say very much about it, except that we decided that we would just build in this testability from the start. Not just automated testing, but also thinking about, like, how are we going to help a QA to test our narrative before we set up the structures for it? And we found that this has benefited, like, we have better velocity in terms of narrative content creation, better velocity in terms of engineering as well. So it's working well for us after all this time. Okay, that is it. I am done. Thank you very much. That is my email address if you'd like to talk to me offline about this. But that's everything I have to say to you today. So I'm very happy to answer any questions that you might have, with the caveat that I might have to answer them offline, because I'm sure you're all much smarter than I am.
Quick question. For your autoplayer type of system, how did you block the system to do infinite loop? Like the autoplayer changing his outfit, and then changing his outfit, and then changing his outfit.
Oh, right. Okay. So for something comparatively straightforward like that, we only had to change the outfit once. Basically, essentially, this is a point where you can leave the house, change your outfit first. But for content, we did have bailouts. We had, for a start, we had, I think, 10,000 iterations. If you hit that number, then stop. That's something that we probably should have thought about a little bit more in terms of how to identify where the loops were. But yeah, for that particular use case, it wasn't a huge challenge for us. There's probably something much more sophisticated that we could have done. Sure.
So obviously you talked about the narrative testing in your project. I'm just curious, by the time you ended up, creating the auto player and all of that stuff, did you have smoke tests or unit tests for the code side, or did that come later with your narrative testing?
Okay, so I'm a massive unit testing partisan, right? Some of our architecture did come built in. So the really, really complex, tough stuff in terms of code is in the story crafting minigame, and we did straight TDD on that all the way through. In terms of testing the other mechanics, it was mostly smoke testing, and we didn't write unit tests. We're doing a lot more of that kind of test-driven design and testable clean architecture on the next project, whose name I almost just said. But yeah, but that's one of the lessons that we learned, that the testable architecture, I think, is fantastic, even if you never write a test for it, because it's just easier to maintain and it's easier to read and it's easier to understand. I'll fight you on that. Does that answer the question? Thank you.
You mentioned that you use random choice for the auto tester. Do you ever consider guided?
Yes, we did. No, yes, we did. And I left it out of the slides because it was very embarrassing to say that we couldn't really do it in the time that we had. But absolutely, that is the next thing that we would have done had we had the time. Look at a way to bias the way the random player chose things. It would have been fantastic. We had all these use cases worked out for that. Like, there are various different characters you can try and get together with in the game, and we knew which choices would make that easier to do. And we had a system where we could put little bits of markup into the choices that wouldn't be rendered by the text printer, and that would really just be instrumentation for the autoplayer. And it would have been fantastic if we'd had the time to do it. But we had thousands upon thousands of choices that we would have had to instrument that with, and we just ran out of road. But yeah, no, that's an excellent insight and an excellent idea, and I really, really wish we'd had the time to do it. It would have been really cool.
How much did this automation testing result in, like, creating more bugs for you to fix in the narrative versus these bugs being fixed before they ever came to QA, before they became bugs already written?
Sorry, do you mean how many of them did we manage to catch before QA compared to what?
Yeah, so this automation testing that you did it result in like many more narrative bugs being created, or was it just a case that this resulted in the bug and them being caught before QA created the bugs?
Definitely the former. A lot more stuff got bugged. It was because it was much easier for Leslie Ann, our QA, to do this. I mean, she's a world-class QA anyway, I should say, but she was able to set the auto tester up to run, do it in batches, get 50 of them to run, go away, make a cup of coffee, or just switch tasks, and then come back with initially a tremendous number of randomly chosen different errors. So yeah, in terms of like bugs getting created and then moving to QA, yeah, it caused a tremendous uptake at first, certainly, yeah.
Hi, thanks
Hi.
for the talk. Did you have to have any difficult conversations to try and convince the money people to get the engineering time to build this auto test system? Because I find as soon as the word random comes into it, you get met with a lot of skepticism, and perhaps that this might not be a complete way to test the game. And perhaps even maybe just to convince yourself. I wonder if you've got any thoughts on that.
We did not face those problems. I think that was in large part because we were a comparatively small team within a small team. So I cannot give any insight or advice into how to turn this into a way that you can persuade the money people. No, I'm sorry. If you have any ideas, I'm happy to hear them. It's always very difficult to do. Just generally with any kind of testing, it doesn't immediately create value. Really, all you can do is have done it and be able to show that it has already worked. Is, as far as I can see, the only option, which is what I would do now on our current project if there were resistance to pushing forward with more testability. Does that make sense? I hope so, yeah. Sure. We're down to our last 5 minutes, but I'll keep talking until they drag me off the stage. So
hello. So my question is, did the automatic testing process change how the writers wrote?
No, it did not. I wish that it had, but we didn't turn our writers into engineers. And of course, there is a risk with something like this that you do, that you end up getting your writers to write like programmers. But they seemed, for the most part, happy to create stuff that was initially quite broken and then fix it later. I'm being very uncharitable towards some extremely talented people, but I think I can say quite honestly that we didn't have this sort of system didn't have a negative impact on the quality of the prose that was produced. I'm happy to be contradicted by my colleagues, but I really hope that was never the intention, certainly, and it wasn't obvious when we shipped that it had happened. Am I done? Okay.
Hello, thank you again. It's kind of a follow-up question. It was a similar question, but did it affect the way your writers created content to maybe fill in gaps, and how did that? You're not a writer, but in terms of like how they approached, we're finding states here that we maybe want to fill in.
Yeah, that's a good question, and I don't know. I mean, I do know that they were proactively writing assertions to make sure that the state worked. With respect to how assiduously they inserted fallbacks for situations like what we call the soft lock problem. If you pop me an email, I will ask the people involved, and I will come back to you, because I would actually, if you send me an email, it will remind me that I will ask this question that I also want to know the answer to. Put it that way. No worries.
Hello, thank you for the talk.
Welcome.
With regards to where you say random choices by the auto player, was it driven by truly random numbers, or did you have some sort of use of like noise so that you could kind of go back and replay over the same seeded data and get some consistency?
It was purely system.random, but we did have a seed. So one of the things that we found that we got in bug reports was Leslie Ann would give us the output and give us the seed. Okay. So we could then just take that seed, run the auto tester for that specific run that had that specific error. I'm going to put my hand to my heart and say that we did not have that initially, but we soon found that it was very useful to have.
Cool. Thank you very much.
No worries. Okay, that's it. I'm done. Thank you very much for your time, Secretary.